Hey there, science fans! Welcome back to another exciting episode where we unravel the mysteries of the universe, one fascinating topic at a time. Today, we're diving into the fascinating world of semiconductors. These tiny yet incredibly powerful materials are the backbone of modern technology. These amazing materials are the unsung heroes of our modern world, powering everything from our smartphones to our cars. Imagine a day without your phone or your electric car. Pretty tough, right? So, what exactly are semiconductors? Well, let's break it down. They're kind of like the in-betweeners of the electrical world. Imagine a spectrum with conductors on one end and insulators on the other. Conductors, like copper wires, let electricity flow easily. They're like the express highways for electrical currents. On the other hand, insulators, like rubber, block electricity completely. They're the roadblocks that stop electrical currents in their tracks. Semiconductors fall somewhere in the middle, having a level of conductivity that can be controlled. This means we can tweak them to either conduct or insulate electricity, depending on what we need. Think of it like a faucet. You can adjust the flow of water from a trickle to a gush, right? Similarly, we can control the flow of electricity through a semiconductor. This adjustable conductivity is what makes semiconductors so versatile. This unique property is what makes semiconductors so special and crucial for building all sorts of electronic devices. From the simplest gadgets to the most complex machinery, semiconductors are at the heart of it all. This ability to control electrical flow is essential for the functionality of devices like computers, smartphones, and even medical equipment. Without semiconductors, these devices simply wouldn't work. So next time you use your phone or drive your electric car, take a moment to appreciate the incredible semiconductors that make it all possible. Without them, our world would be a much different place. Now let's get a little more technical, but don't worry, I'll keep it simple. We're going to dive into the fascinating world of semiconductors and how they control the flow of electricity in our devices. Imagine a drawbridge. When it's down, cars can cross freely. This is similar to how electrons move through a semiconductor when conditions are right. When the drawbridge is up, traffic stops. In the same way, a semiconductor can block the flow of electrons under certain conditions. A semiconductor works similarly, but instead of cars, we're talking about electrons, those tiny particles that carry electricity. These electrons are crucial for the operation of all electronic devices. By adding impurities or dopants to a semiconductor material like silicon, we create areas where electrons can flow easily, the drawbridge is down, or where they get blocked, the drawbridge is up. This process is known as doping and is fundamental to semiconductor technology. These areas are called p-type and n-type regions. P-type regions have an abundance of holes, which are places where electrons are missing, while n-type regions have an excess of electrons. By putting these regions together in different ways, we can create electronic components with amazing abilities. For instance, we can build diodes, which are like one-way streets for electricity, only allowing it to flow in one direction. Diodes are essential in converting alternating current, AC, to direct current, DC, and are used in many electronic devices. Or we can create transistors, which act like tiny switches, turning the flow of electricity on and off millions of times per second. Transistors are the building blocks of modern electronic devices, enabling everything from computers to smartphones to function. When we combine many of these components, we get integrated circuits or microchips, which are the brains of our electronic devices. These microchips can perform complex calculations and process vast amounts of data at incredible speeds. So the next time you use your smartphone or computer, remember the tiny drawbridges for electrons that make it all possible. These incredible technologies are the result of decades of research and innovation in the field of semiconductor physics. Speaking of transistors, these little guys are a big deal. Invented in 1947, transistors are the building blocks of modern electronics. They're like the tiny switches that control the flow of information in computers, smartphones, and countless other devices. Before transistors came along, electronics relied on bulky and unreliable vacuum tubes. Imagine trying to fit thousands of light bulbs into your phone. That's essentially what early computers were like. Transistors changed everything. They were small, efficient, and could be mass-produced. This paved the way for the miniaturization of electronics, leading to the powerful and portable devices we know and love today. Thanks to semiconductors, computers went from room-sized behemoths to sleek laptops and powerful smartphones we carry in our pockets. The incredible shrinking act of electronics is all thanks to our tiny semiconductor friends. Think about all the things your smartphone can do: make calls, browse the internet, take pictures, play games, and so much more. None of it would be possible without the millions, even billions of transistors etched onto the tiny chips inside. And it's not just our phones and computers. Semiconductors power our TVs, gaming consoles, cars, and even our kitchen appliances. They're everywhere. But wait, there's more! Semiconductors are also driving the exciting world of the Internet of Things, or IoT. This refers to the growing network of everyday objects that are connected to the internet. Think smart refrigerators that order groceries for you, thermostats you can control with your phone, or even fitness trackers that monitor your activity levels. All of these devices rely on semiconductors to sense, process, and communicate information. The IoT is revolutionizing the way we live, work, and interact with the world around us, and semiconductors are at the heart of it all. Section 6. Semiconductors in Healthcare. Enabling life-saving innovations. Semiconductors are also making a big impact in the world of healthcare. From sophisticated medical imaging equipment like MRI machines to life-saving pacemakers and insulin pumps, semiconductors are helping us live longer, healthier lives. These tiny wonders are even enabling the development of cutting-edge medical technologies like gene editing and personalized medicine, offering the potential to cure diseases that were once considered incurable. Section 7. The economic impact of semiconductors, a global powerhouse. The semiconductor industry is a global powerhouse, driving innovation and economic growth worldwide. The design, manufacturing, and application of semiconductors create jobs, boost economies, and fuel technological advancements across the globe. From Silicon Valley in California to tech hubs in Asia and Europe, the semiconductor industry connects the world through trade, collaboration, and the shared pursuit of technological progress. Section 8. The future of semiconductors. Smaller, faster, more powerful. The future of semiconductors is incredibly exciting. These tiny components are the backbone of modern technology, enabling everything from smartphones to supercomputers. As we look ahead, the advancements in semiconductor technology promise to revolutionize our world in ways we can only begin to imagine. Researchers are constantly pushing the boundaries of what's possible, developing even smaller, faster, and more energy-efficient chips. This relentless pursuit of innovation is driving the industry forward, making devices more powerful and efficient than ever before. We're talking about things like quantum computing, where semiconductors could be used to build incredibly powerful computers capable of solving problems that are impossible for today's machines. Quantum computers have the potential to transform fields such as cryptography, materials science, and artificial intelligence. Imagine a world where complex simulations that currently take years to complete could be done in a matter of seconds. This is the promise of quantum computing, and semiconductors are at the heart of this technological revolution. We're also looking at new materials and manufacturing techniques that could revolutionize the way we build electronics. Innovations in material science, such as the development of graphene and other two-dimensional materials, are opening up new possibilities for faster and more efficient semiconductors. The possibilities are truly endless, and the pace of innovation shows no signs of slowing down. As scientists and engineers continue to explore the frontiers of semiconductor technology, we can expect to see breakthroughs that will change the way we live, work, and interact with the world around us. It's safe to say that semiconductors will continue to shape the future of technology and our world for generations to come. From the devices we use every day to the cutting-edge technologies of tomorrow, semiconductors are the key to unlocking a future of limitless possibilities. Section 9. Conclusion: Semiconductors shaping the future we live in. So, there you have it, folks. Semiconductors may be tiny, but their impact is enormous. They've revolutionized the way we live, work, and interact with the world around us, and they continue to drive innovation and progress in countless fields. From our smartphones and computers to life-saving medical devices and the Internet of Things, semiconductors are truly the building blocks of our modern world. So next time you pick up your phone or turn on your computer, take a moment to appreciate the amazing science happening inside, thanks to the magic of semiconductors.